recording, I say. There we go. All right. So this is 129S, Securing Web Applications. And by the way, you should be doing Pico CTF. It's right here, and I'll put the link on in the chat as well. This is Carnegie Mellon's Beginners Capture the Flag competition, a training event, and it's very good. So I recommend signing up and doing some of these puzzles, and it's worth some extra credit. I haven't quite figured out how many points, but I solved a few of them, and if you turn in a scoreboard of this, I'll give you extra credit for it. It's particularly appropriate to my technical classes, 127 and 129S. There is a whole category of puzzles called exploit development and a whole category called web exploits. But solve any puzzles you like. It's good for you. And the good thing about Pico CTF is it's intended for beginners, so it starts from very easy puzzles and it goes all the way up to very hard. There are far more puzzles at each level of difficulty than in most common type of CTF. So it's very friendly. Even if you're a complete beginner, you'll find some there you can solve. And if you're more advanced, there will be ones to challenge you. So I highly recommend doing this. The official competition goes on for about 10 days, 15 to 29, about 15 days. And after that, it archives the puzzles. You can keep doing the old puzzles. So it's a good thing to do. All right. And so today, I'm going to finish talking about databases. And then we'll talk about cross-site scripting in the Web Security Academy. So we are down here, finish talking about data stores, and then cross-site scripting. So here's the slides for databases. I think that'll do. All right. So if you have a possibility for SQL injection, people that don't just leave it wide open will then try to block it by doing things like removing quotation marks. Let's see, how did people find the reading? Oh, I don't know. I'll let you people talk about that. All right, so anyway, so if you block quotation marks, that will block the simple kind of SQL injection into a string field, but you can inject into a numeric field without any quotation marks. So simply blocking quotation marks is not enough to completely stop SQL injection. And you can also sneak characters in past a character block. And this is why deny listing, where you list bad characters and block them, is considered a weak defense because there are ways to sneak characters through. For example, here's the query where I select where ename equals Marcus, and you could encode these apostrophes as character 109 and then use this double pipe, which I think is Oracle, and it's plus in MS SQL, and then just add this. So you can refer to these numbers, and therefore you can make it so the database will find an apostrophe there, but you did not type apostrophe anywhere. So the apostrophe filter will be bypassed. And that's the problem with any kind of deny listing where you try to deny a list of forbidden characters. There are ways to sneak a character in without explicitly typing it. And there are a lot of ways to sneak it in. So if you block the comment signal, like we try to do this injection, apostrophe or 1 equals 1 dash dash, but it blocks the dash dash, so you can't make the comment at the end. Then you can just try this, apostrophe or A equals A, where there's a missing apostrophe here, and now when you put that in for the name, it will turn into a valid query where name equals blank or A equals A, and it uses up the apostrophe, so you don't need a comment. So that's one way to get around it if they're blocking comment characters. If they block the word select, you can try changing the case, adding a null byte in front, putting a select inside a select, so when the filter comes and removes this one, the remaining characters are another select. You can spell out the select with hexadecimal codes for each character, or even double hex encoding here, which is particularly effective on old versions of IIS, Microsoft's web server, that actually doubly decoded data. So it would decode this %25, which is the code for percent, and then it would decode it again. The %53 would turn into an S. So these are strange patterns of characters which in fact will be interpreted as the word select. And then you can use comments. So if you can't put in spaces, you can just put a comment in where the spaces go, and you can even put the comment inside the keyword. So this is select with a comment in the middle of the keyword, and therefore it won't be caught by a simple filter looking for the word select, but it'll still be interpreted by the database as select. All right. And then there's second order SQL injection, where you do not inject directly in the immediate query that shows a page on the screen. Instead, you inject data containing SQL commands into the database, and when that data is used later, it takes effect. So, for example, you can register an account with an apostrophe in the name. If you allow people to have apostrophes in your name, which, by the way, you probably should, because a lot of people really have apostrophes in the name, then the correct way to put it into a database is to put 2 apostrophes there. That's how you do it, and it'll put an entry in the database with a database. Yeah, backslash apostrophe is the way you do it in a bash command line. I'm not sure it would help you in SQL injection, but it might in some circumstances. Anyway, so now you've managed to put its data in the database with an apostrophe in it. Now when you try to use that database, like you try to input an old password, and the username includes an apostrophe, then when you try to do a password change and it tries to look up the old password, it'll be a syntax error. That apostrophe will cause this to have an odd number of apostrophes and it'll crash. So you can put data in the database, but when it's used, it creates an error. But the fact that it creates a syntax error means that you can control the database by putting in something more careful. So what you do is you put in a user with this name, apostrophe or 1 in, select password from user where username equals admin, and then a dash dash. And when you perform a password change, it will have an error message. And the error message will tell you what the error was, and it's going to evaluate this thing in parentheses and print the result there by thinking it's telling you what the error was. So it will expose a database, it will expose the password in the error message. ORMs. Yeah, I haven't done the ORMs, but some of the students might have a good tip for a clue for that. So this one is a second order SQL injection, this famous cartoon. The mother named her child Robert apostrophe and drop table students dash dash, so that when they try to print out a list of student names or something, it will run this query and drop table students and lose the records. But that's second order SQL injection, not the kind that just steals data immediately, but the kind that poisons a database so when it's used later, it executes a query. All right, so then there's other kinds of advanced exploitation. Yes, this cartoon was very important. This cartoon was actually read by a major corporation, I think LinkedIn or something, and the executives asked their engineers, are we vulnerable to this? And many people patched their vulnerabilities after reading this cartoon. This helped executives understand SQL injection, which many of them had not previously understood. A lot of these XKCDs really have technical things right, and they help communicate it to people. So the normal SQL injection attacks that we've done before, you would have a page with some kind of data you can put in, and then some data appears on the screen, so you can easily pump it out. But what if the results are not exposed? If your query is run, but it does not print any data from the database on the screen, then you can do various things. For example, you can do like what Bobby Tables did and just do a destructive attack that doesn't steal data. You could drop a table, or you could use shutdown to turn off the database server. These are things that you could do with SQL injection. Or you could retrieve data. Now, if you have data on the screen that came from the database, but it's only numbers, and you cannot find a text field, then you can only get numbers out. So what you can do is convert characters to numbers using ASCII or substring. So you can get one character at a time as a number. So here, we've done this before in the blind SQL injection. Substring admin11 will give you the first character in admin. And ASCII of A is 65. So you can convert letters to numbers and pump out the numbers in a numerical field. That's one way to get data out. And you can use an out-of-band channel. Try to find some other way to sneak the data off the server. Some of them will let you make network connections inside the query language. So you can go to a server called mdattacker.net on port 80 with a username and a password, and it'll connect to this server and then send data directly to the server, which is listening. So this is a sort of reverse shell from inside SQL. Here it is in Oracle. There's a thing called UTL HTTP, which will make a request. And now you can just send some data back to it on that port. You use a netcat listener, and it will see the data coming in. You can also send a DNS request. You can use get host name and then try to resolve a domain name. So you can just put it in a domain name. Like here's the DBA user's password and then puts .mdattacker.net. So it'll try to resolve the name of a server, which is their password, .mdattacker.net. And if you control the DNS server, you will see a query coming in asking to resolve that. What allows you to send the data over? Is there no auth? Well, a DNS server doesn't need any auth. DNS servers are typically open and can get a request from anybody, and HTTP servers can typically get a request from anybody. One of these back here actually used a user account and password, so I guess that's for some kind of authentication on the server. But yeah, if you typically run an open server when you're doing this. All right, and so you see this, you'll get a password.mdattacker.net, and even though this server does not exist, the query will go to the authoritative server for this domain, which would be under your control, so you can look in your DNS server logs and you'll find the password. Yeah, that's how you do it. You look in your DNS server logs is the easiest way to do it. Configure your DNS server to record all queries, and if anybody tries to resolve this query at your server, then it'll appear in your logs. In MySQL, we've done this before. You can select into an out file and then just refer to a local file, and that would save it in a file in there. And apparently you can sometimes even I think this is actually sending it to a share on another server. Yep, set up an SMB share on your server with anonymous write access. I haven't tried this. Over the internet, that's a kind of screwy thing to do, but maybe it would work. You can actually go to it like a Windows share remotely. That's pretty cute. Have to try that sometime. All right, and then of course you can execute shell commands. If you can upload a file with a file name ending in PHP, you can usually execute it, and then you have a PHP shell. Once you have a shell of some kind, then you can use the operating system commands like TFTP, mail, and telnet to make outgoing connections. Or you can just copy data into a file in the folder containing web pages, and then you can just view it through the browser. So there's a lot of ways to sneak data off of a server. All right, let's take a look at a Kahoot. And yeah, I saw someone say there's a lot of data. It certainly is. I found web hacking to be sort of overwhelming at first, but you get used to it. Web design is just very complicated. There's so many ways to do it. But, you know, you just get what you can and you go over it and over it. I'm not the best at web hacking. I'm getting better, though. The Web Security Academy is a good way to learn it. Yeah, that's right. You don't expect to get all this the first time. Yeah, it's the same thing with exploit development and the Windows API and stuff. You just have to go to it, expect to keep back to it, and you sort of gradually get used to it more and more. All this hacking stuff has just an awful lot of information. Nobody knows it all. You know, you pick up some and you learn more as you go ahead. Yeah, the book is pretty dense, so you're probably not going to get it all the first time you read it. Just get some of it. And as you hit it again and again, you'll keep learning more. All right, maybe that's enough. All right, so if comment signals are blocked, what would you use? Yep, that's the one that gets away from using comments. Uses up that apostrophe at the end, so you don't need that comment symbol. All right, which one will expose a secret in an error message? Yep, actually, I'm not sure what would happen if you had a password with the letter 1 in it. I think it might find 1 in there, but anyway, apparently this condition is always illegal, and so this parentheses thing comes out in the value of the error message. All right, how do you bypass keyword filters? All right, this is the one. Removing select will just create another select. All right, so here's the one. What kind of SQL injection is Little Bobby Tables? Yep, that's second-order SQL injection. The data goes in the database, but when you try to use it, it runs a command. All right. All right. All right, so then if you don't return any data at all that you can see, then you got blind SQL injection. Now, if you could find an out-of-band channel to send some kind of network traffic to your server you control, that would be good. But if you can't figure that out, then you can still get data by using some indirect procedure like timing. So here's one. You're selecting your username as Marcus and password equals secret. You could put in admin and then a comment signal. We did this last time. And this will log in as admin regardless of the password, because the comment will remove the password check. So you might be able to log in even though it's not returning any data to you. You might be able to do that kind of exploit. And here's one. Now this will log in as admin apostrophe and 1 equals 1 dash dash. But this one will not log in. Username equals admin and 1 equals 2 because the second condition is false. So this is what we did in the early project of SQL injection. You created a condition where you can tell the difference. This will log in and this will not log in. So you can tell if this second condition is true or false. And now you can find out the true or false answer of one question. So now you can look to see if the first letter here is 65, which is A. It's true. It's not 66. So you can now do true or false questions and pump out data, and that's the procedure of blind SQL injection. You ask true or false questions. That's an and not an or. That's right. That's right. That's the point. These things both have to be true. So you log in as username equals admin, and the first letter of this is A. So that's going to be true, and you'll get in. This one, username is admin, and the first letter here is B, and that's not true, so you won't get in. So that's your one bit of data. Whether you get in or not, whether you're logged in or not, is your one bit. All right, you can also induce conditional errors. So here I select 1 over 0, which is going to crash, where this condition is here. And if the condition is true, it will cause an error. If the condition is false, it will not attempt to select 1 over 0. What do we do when we want to use the false one? Well, you don't. See, the point is, this one is just so you can see it. What you would do is you would make this like select password from database, where username equals the username you want to get in. And then you do all that, and then, or here you say, and substring of password 11 equals A. Then if you get in, that means the first letter of the password is really A. If you don't get in, that means the first letter of the password is not A. That's the point. We did this a while ago. Let me just bring it up here. This was the first SQL injection project. And let me get there to remind you. Here. This one here. There was a blind SQL injection at the end here. And so here you can, for example, do this. This will tell you if the length of the database equals 1. If it's true, you'll see a result. If it's false, you won't see results. So the length of the database is not equal to 1. And here, if you change that to greater than 1, then that's true because you get an answer. So this is blind SQL injection. Yeah. Wondering about choosing something. Yeah, the only reason they choose something as patently false is just as a demonstration. That's all. Yeah. All right. But you test it with something you know to be true and something you know to be false to make sure it's working, of course. All right. So here, if you're trying to see if an account exists called DBS NMP, then you make a select query here, select username from all users where username equals DBS NMP. So this will have a result if there is such a username. And so this will only be true if that username exists. And if it's true, you'll get an error, 1 over 0. If it's not true, you won't get an error, 1 over 0. So this would be a case where you can gain data from the database exposing errors, which, by the way, you're not supposed to do on production servers. You're not supposed to show SQL errors, but sometimes people do leave that turned on. So here you'd see if the username AAA exists. With that query, you'll see an error if that does exist. You can also use time delay. This will wait for 5 seconds. So if the user equals SA, then it'll wait for 5 seconds. So you can just see how slow it is to respond and get an answer to a yes or no question. You can, so now here you are again. If some string you're looking for, the first letter is A, wait. If it's B, wait. One of these will wait. And the one that waits tells you what that first letter is. You can just single bits if you want to. You can take the first letter and turn it into a number, and it with a number. This will get you 1 bit of the 8 bits in that letter, 7 bits if you want to get picky. And then you can see if that 1 bit is 0 or not. So you could use this sort of mathematics to tease out the bits one by one. In MySQL, you can use a sleep command. In older versions, you could use a benchmark command to do some calculation that will take a long time. There's various commands available just to waste time. In Oracle, you can use URL HTTP to make an HTTP connection to a server that does not exist, and that will take some time to time out. So again, you'll have a delay. All right, so this is the one that looks, this parentheses thing will select to see if there's a username named DBS NMP, and if that's true, it will try to perform this request, which will make it slow. And if that's false, it won't, so the answer will be fast. All right, and we can go beyond this. If you want to take over the server and not just steal data from the database, one thing you might be able to do is reach data in the database that's used by other applications. That's a possibility. But it'd be even better if you could just take over the operating system of the database server and then pivot. Use the database server, put malware on it, and use it to jump on and start doing lateral traversal through the network. So you can make network connections back to your own machine to exfiltrate data, and you can extend the database functionality. If you get Database Administrator, you can reintroduce disabled functionality on the database. The XP command shell is the famous Microsoft thing. This lets you execute command shell commands from inside Microsoft SQL. It's now disabled by default. Used to be on a long time ago, but you can now execute commands like ipconfig going into a file. Just handy right there. There's all the ones that read from the registry and write to the registry, and you can do pretty much anything on a Windows machine if you can get to the registry. Now, they're disabled since 2005, but if you're the database administrator, you can just enable it again, and then you've got command shell injection. Yep. MySQL lets you load a file. You can go into out files, so you can now read and write to files. So you could, for example, write to configuration files like this one, which tells it to trust all hosts, or other things if you have the right privileges. And you can, of course, use tools. Doing SQL injection by hand is a good learning tool, but almost no professional pen testers do it that way. They use SQL Map. And see, if you've used SQL Map, if you did the extra credit part of the SQL project, it'll automatically brute force all the parameters to try to find injection points. It'll determine, try appending various characters, try to perform a union attack, try to inject nulls until it finds out how many columns there are, and find a column with a varchar or string data type. Then it will concatenate things. It'll try Boolean conditions, and then it'll try time delays. It'll do all that for you. That's why you run SQL Map, it takes a while. It tries all these different attacks until you get in. It's very nice. All right, so you just give it a command, the URL you're trying to attack, and give it a command like dump all the data you find, and it will run for a while and then find all the data if it finds a vulnerability. It's very nice. I was doing a CTF a couple weekends ago with Caitlin, and I was doing manual SQL to see the SQL injection. She just used SQL Map and got right in, because I was sort of interested in playing with it. She was more serious about getting to the answer. Anyway, there should be another Kahoot. Here they are. 9B2. I'll give it a few more seconds. All right. All right. You get one yes or no question per query. Yeah, conditional errors is the best answer there. Well, there was one example where you actually got a whole password from an error, but normally you only get one fact, true or false. All right, which one exposes data from local files? Yeah, that's load file is what reads from local files into out file, writes to local files. But this is what loads data from a local file. All right, how do you get Windows command injection? Yep, XP command shell. And to create a local file. Yep, that's into out file. All right. So, all right, ECC, I think I know who that is from before. All right. Good, Luana's won twice. Whoa. All right. All right, good. We've got enough time to continue here. So, if you want to block SQL injection, then the simplest thing is, of course, blocking apostrophes, but that won't stop injection into numerical fields. And if you allow apostrophes in database fields with doubling, you might have second-order SQL injection. Stored procedures. Some people say this, the stored procedures will prevent SQL injection, but they won't. All they do is they define a procedure that does something. You can refer to it by name, but it doesn't prevent SQL injection if your stored procedure has user-controlled data somewhere in a parameter. It's not the fact that it's stored or not that makes it safe. The thing that makes it dangerous is that part of this query includes user-controlled data. So you can define a procedure, and the user can still inject things with using command shell and so on. Parameterized queries are what you need. This is where you don't just have the query as just a string, which is going to be parsed. You specify the structure with placeholders for input data. And the application specifies what goes in the placeholder, so the data object is treated only as a data object, and it cannot be interpreted as a command with a delimiter in it. So this is what it looks like. You define the structure, select name where name equals. This is the vulnerable code, where you're going to make a string, you put a quote here, then you put in the user supplied name, then you put in another quote. That's the problem. This is the one that we've been injecting into, where the magic character quote, and then you put in data that came from the user, which might also contain quotes, and quotes in there will be matching this quote from the developer. That's what you want to avoid. So the parameterized version, you put a question mark there. ename equals question mark, and then down here you tell it what's going to fill in that parameter. The name goes where the question mark is, but it's not interpreted with a character like an apostrophe showing where it starts and ends. This is what you do. Now you can have any kind of data here, can include quotes or anything, and it will just do what it should do. It will look for a name that includes that quote. It won't get confused and decide that part of the name is a command. That's a parameterized query, and this is considered a perfect solution for SQL injection. I've never heard of anybody finding any way to do SQL injection anymore if you always use parameterized queries. So you have to always do it all the time. It would be much safer because it might not be easy for you to realize exactly what the user can control. If user data is changing the name of the table or column name, then instead of putting user data directly in the query, you should just force it to choose from a list of known good values, and only those. All right, and you can't use parameter placeholders for a sort by or where or anything. You can't have any part of the query that's under the user's control, as we've seen, because they can use union or other tricks to combine two queries together. All right, the application should use low privileges, so you're not going to be running as a database administrator. So even if they find an injection, they won't be able to get database administrator and turn on XP command shell and things like that. Put on your vendor patches, patch things when vulnerabilities come up. And then, of course, there's NoSQL. I don't know how many people are still using NoSQL. It was all the rage a few years ago. I think Mongo is still pretty popular, though. NoSQL doesn't require structured data. In SQL, every field has to be a text or a number or money or something like that, and a nice structured format. In NoSQL, you don't have to. You can store unstructured data. I think Facebook was the first big company to really make popular to use Cassandra, a NoSQL database, and I think even they eventually knocked it off. But anyway, so you can now you can search for things by key value lookup, XPath, or JavaScript. So here's a Mongo login. Return username, this password equals password. All right, you're getting a function, and then you decide if it's set, you're logged in, or else you're not logged in. This is what it looks like. It looks kind of like SQL code. All right, so you log in with this username, and now this is JavaScript code to inject into to send data to Mongo. And now you're putting a username from the user here with those apostrophes. So if you put in this, it's going to turn into this. And again, you've accomplished it again. Return this username equals Marcus. And the start of a comment has commented out the rest of this. So you're not going to check the password. So you can inject. Yeah, I think it's JavaScript, but that does look like PHP too. Anyway, here's another injection. This username and any password. This will be interpreted as this parentheses here and that separately. So the end result is it will be always true. And it will take whatever effect the query would have if it was true. Log in as the first user, dump all the data in the database, things like that. Here's XPath. XPath is an XML data store. This is XML, where you have opening and closing tags for everything. So we have an object called an address book, and it contains object called addresses, and those contain first name and password and email and so on. So this is structured data, and so there's passwords in here. And to retrieve all email addresses, you'd make it look like this. Address, in the address object, get the email and show me the text in there. This would show me all the information with this condition, surname text equals DAWS. So there is an injection. This query would receive a stored credit card number, get me information from DAWS, and the password equals secret, and now give me the credit card. So this injection would go here in the password field, and now I'll be able to get it even though I don't have the password. And I think I'll also get all the users, not even the ones that just have text equals DAWS. Although it's a little hard to read here, you can see that although it's a different language, the general principle remains the same. You can still do injection. So here's some strings that will break the syntax and give you syntax errors, and here's things that will change behavior without breaking syntax. So that's one way to detect that there are the flaws. And so you can prevent it by filtering inputs to an allow list, remove all these characters. That's one way to do it. And then there's LDAP. This is what Microsoft Active Directory uses to send directory information when you log in and to identify who you are on a network, and also open LDAP. This turns out to be safer just through its structure. LDAP queries look like this. Match a username. If you want to match any of these conditions, you have the OR operator, or any of these conditions. Name equals search, SN, OU equals search term. To match all the conditions, you put an ampersand at the start, and then all these conditions must be true. And just that syntax is enough to make it hard to inject. Because if you can inject, you might be able to inject something in, say, this username, but you can't inject this condition, which was earlier, like and or. So you can't construct this or 1 equals 1. In principle, you might be able to inject something, but in practice, it's hard to do these good injections that accomplish much of anything just from the structure of the language. All right, so let's look at another Kahoot. Good, people coming in. All right, that might be enough. All right. All right, what's the best defense? All right, parameterized queries. The parameters specify where the data goes in, and data cannot be misinterpreted as code. All right, what defense might open up second-order SQL injection? All right, doubling the apostrophes to store data can lead to storing data which will cause a SQL injection later. All right. So which of these is least susceptible to injection? All right, LDAP, as we talked about, because the logic comes at the start where you can't get at it with your injection. All right, and which system uses queries that look like that? Yeah, that's XPath, which I've never used. There are so many web technologies. All right, and what system has conditions like that? All right, and that's LDAP. All right. All right, Pedro's won twice, and so has Eileen. And so has Woot. Good. All right, let me stop the video.